Okay, this is day 1 of 4.2, and we're going to be graphing quadratic functions that are in vertex form. So the other day we talked about standard form, which was y equals ax squared plus bx plus c. But now we're talking about vertex form, which is y equals a, and then parentheses, x minus h squared plus k. So make sure that formula is in your notes labeled vertex form. So we talked about how the parabola y equals x squared goes through the origin. And we also talked about how if we had y equals 1/2 x squared, that was wider. And the other one was y equals 2x squared, how that's narrower. But they all have a vertex at the origin. So vertex form is going to help us see how our parabola shifts horizontally and vertically. So for example, if I had y equals a, whatever a is, x minus 2 squared plus 1. So negative 2 will be my h, and 1 will be my k. So this tells me I need to go to the right 2, and this tells me I need to go up 1. The reason we go to the right is usually in the positive direction. Even though our 2 was negative, we do the opposite. So we had a negative 2 as our h. Negative usually means go to the left, but we do the opposite, so we're going to go to the right 2. So if I was at my origin, I would need to go right 2, up 1, and I would plot my vertex for my parabola. So looking at another example, if I had y equals a times x plus 2 squared minus 1, then I would have 2 as my h, negative 1 is my k. So this tells me I need to do the opposite of positive 2, which is go left 2, and negative 1 means I need to go down 1. So on my axis, I would go left 2, down 1, and plot my vertex. This is assuming that A is positive, right? Because my parabola is opening up. And that's what this last bullet point is telling me. The graph's going to open up if A is greater than 0 and down if A is negative. And we already saw that with our standard form. The other bullet point is the axis of symmetry is x equals h. So all that's telling you is that the symmetry is going to go through my vertex vertically, and we already saw that. And it's also saying that the vertex is hk. So that's helpful to us. So make sure you have that in your notes, and also horizontally by the h and vertically by the k. Okay, so now we're going to practice graphing a quadratic function in vertex form. So, like we did with standard form, I'm going to write down my constants. So a is negative 1/4, and h is negative 2, and k is 5. Remember, for h we do the opposite. So up here was a plus 2, so our h is a negative 2. And this little guy should be the exponent. So looking at our a, since negative 1/4 is less than 0, we know that our parabola is going to be opening down. We also know from the slide before that our vertex is h comma k. So we have negative 2 comma 5 is our vertex, and we can go ahead and plot that. And then we know that our symmetry, line of symmetry, goes through that vertex vertically. So after we have our vertex in our axis of symmetry, we need to find another point so that we can complete our parabola. Now step 3 says evaluate the function for 2 values of x. Well, really we only need to evaluate it for 1. We can evaluate it for 2 if we want a more precise graph. So I want to know when it hits my y-axis. And when it hits my y-axis, what is my x value? My x value is going to be 0, right? Any point on the y-axis, my x is 0, right? I haven't moved left or right. X is 0, and y goes up or down. So if x is 0, then I can plug that in to my equation, which is what I'm going to do. So this is evaluating this function for 0. And once I simplify, I'm going to get negative 1/4 times 4 plus 5. So negative 1 plus 5, which gives me 4. So at the point 0, 4 is where it touches the y-axis. Now using what I know about symmetry, I know that this point is 2 away from my line of symmetry, so I need to go 2 away from my line of symmetry on the other side of that line. Now I have 3 points and I can complete my parabola. As you can see, their graph down here is a lot nicer than mine, and that's because they also picked the value x equals 2, and they plugged that into their equation and found y equals 1. So this is the point 2, 1. And that's what it talked about evaluating for 2 values. So they just found another value and then did its point of symmetry across the line. And that's why their graph is a little more neat than mine. Okay, so let's walk through another one together. So let's find my A, my H, and our K. So A is 1, right? There's a value of 1 out here. H, so we take the opposite of positive 2, which is negative 2, and our K, which is negative 3. So the value of A tells us that our graph is going to be opening up, and HK tells us that our vertex is going to be at negative 2, negative 3. Right, because we moved to the left 2 and down 3. So I'm going to start to plot my graph. So we need to go left 2, down 3, and plot our vertex. So what else do we know? Well, we know our line of symmetry goes through that vertex. And now we need to find another point that we can plot. I always like to plug in 0 for x. That way I'll find my y-intercept. So when x is 0, let's find out what y is. So I'm going to have 1 as my y, and that's when x is 0. So x is 0 and y is 1. That means I need to go up 1 and plot my point. So this point is 1, 2 away from my line of symmetry. That means I'm going to go on the other side of my line of symmetry 2 places and plot my other point. And now I can plot the rest of my parabola. It may be important to note that this line of symmetry is the line x equals negative 2, right? A vertical line through negative 2. Okay, I would like you to try this one on your own, so find your coefficients and graph the parabola. Hopefully you got something similar to what I got. So first I found my coefficients. I realized that it was going to be opening down, and I knew my vertex was at opposite h comma k, so that's -1, 5, and that means it moves to the left 1 and up 5. Once I found my vertex and my axis of symmetry, I wanted to know what the y value was when x was 0. So I plugged in 0 for x and I found y, and I plotted the point 0, 4. And I used my line of symmetry to plot my other point, and then I completed my parabola. Okay, I want you to try this one. Pause the video and good luck. And you should have gotten something similar to what I just got. So bring your questions to class tomorrow and we'll go over some more examples. See you then.